Pink, are you
Yep.
here?
Yes, I'm
So I
here.
give back the floor to you.
Right. So in the interest of time, we are going to skip the next coffee break. We are about 20 minutes late. We will have a break after the panel discussion. So before the break, we have two talks. The next talk is actually from our co-organizers, Yu, Maximo, Berg, and Joy will give a review on recent competitions.
All right, so for this particular talk, we're going to break the talk to 4 different sections, and Burke is going to be the first one. We actually do not have 2 talks in this section, if I remember correctly. I think we have 1 talk, then we have a panel discussion. So I guess after this talk, we will give this host to Hao, and he will take over for the panel discussion. All right, so Burke, please.
Sure. So hello, everyone. We are Maximo, Joe, and you, and I will be presenting our recent work about recent challenges and progress in the latest grasping and manipulation competitions. So we will be, first of all, talking about some benchmarks that are already published in literature and what kind of challenges that they pose to the community. And then we will be talking about the competitions and challenges that we have been organizing in the past, and some conclusions that we got from that. And one of those challenges is actually the manufacturing challenge. So we will discuss some task performances regarding that. And we also have a service robotics challenge, and we will talk about some observations regarding that competition. So first of all, I will very briefly talk about some benchmarking protocols. So actually, when we look at performance assessment in robotic manipulation, maybe we can roughly categorize them into 3 parts. One is like competitions, like grasping and manipulation competition is one example of that. Amazon picking challenge, for example, is another one. Another one is benchmarking protocols. These are usually designed for implementing them in or on laboratories, and some cloud-based benchmarking tools or platforms that we can remotely connect and test our algorithms and strategies. So when we look for the benchmarking protocols, as I said, these are mostly about defining some experimental procedure that everyone can implement in their own labs. So, for example, some descriptions of these procedures would be the initial state and conditions of the experimental setup, like prior information that is available to the setup, and step-by-step description of the experiment. And if there are, the benchmark might restrict the users from using some particular information, for example, or using some particular hardware in a particular way. And then a benchmark would also give us some evaluation metrics about how to assess the performance of a robotic system. And sometimes these benchmarks are accompanied with data sets. So quite recently, actually, we have organized, so Maximo here, Maximo Roa, Yusan, I, and 2 other colleagues organized a array letters special issue that was on benchmarking protocols for robotic manipulation. So that's the title of the special issue. And in that, we have 14 papers published. And so these are only benchmarking protocols, like very well-defined benchmarking protocols for the experimental procedure, assessment tools, baseline results, and some multimedia attachments to pretty much all of them. And maybe we can, again, roughly categorize them into 3 types. One is like mechanism level benchmarks, the other one is algorithm level benchmarks, and another one is system level benchmarks. So for the mechanism level benchmarks, an example is, for example, assessing the robotic abilities of a robotic gripper. So this would be about evaluating the grasp strength, for example, or finger strength, or when the grasp might break. And you can see here one example that the authors prepared an assessment tool that is partially 3D printed and partially sensorized. And you can actually assess many different aspects of a mechanical design, a mechanical gripper. Another one is algorithm level. This this is mostly about measuring the performance of an algorithm. One example is, for example, the measuring the performance of a grasp planning algorithm. In this particular example, the authors define some objects and some poses within those objects, and define the experimental procedures that is targeted to assess the performance of the grasping algorithms. Another example here is benchmarking in hand manipulation performance, again, with very well-defined assessment strategies and experimental procedures. When we see the third category, this is the system level benchmark. This is basically making the systems execute a certain task. And this is usually an end-to-end performance evaluation. For example, Amazon Picking Challenge inspired benchmark, you can see here, is one of them in which they define the poses of these objects within a shelf and along with some experimental procedure details. And another one is box and blocks test, again, published in this SI. So Amazon Picking Challenge 1 is not published in the SI, but this one was in this SI, in which the users basically are expected to transfer some wooden blocks from one container to another. And there are various target domains here that can be robotic grasping, bimanual manipulation, even aerial manipulation. There are a variety of applications. And there are some platform related issues, of course, when we use benchmarks in our own environment, in our own labs, because people are using different strategies and different hardware usually when they are assessing a particular algorithm, for example. And I want to discuss those more in another presentation in this workshop. But definitely one good solution to that is cloud-based benchmarks, of course, that has been presented in this workshop in several occasions. But when we look at this whole picture, it's usually that in competitions, we have the assessments with a judge. So each of these, like basically competitions, benchmarking protocols, and cloud-based benchmarking, these have all different properties, different outcomes. And one of them is, for example, are assessed with a judge. The benchmarking protocols are usually self-assessed, and cloud-based ones can be a judge or an automated, oftentimes it's automated assessment. And while in competitions, we would not expect novel solutions all that much, but in the other two, we would expect novel solutions. Whereas we have platform independent performance assessment in cloud-based benchmarking, but in benchmarking protocols and competitions, we usually have platform dependent results that we need to assess. So this was my part, summarizing some benchmarking efforts in recent literature.
Yes. So let's move on now to some description of the competitions. So this is really just to bring to your mind some images or some ideas of what has happened in the previous competitions. There are different levels that can be considered for the competitions in robotics. Either they include grasping, manipulation, assembly, or even mobile manipulation. But most interestingly also, some of the competitions have fixed tasks, actually most of them. And that means that the teams can usually engineer the solution to solve those fixed tasks. And then the question is, how generic is that solution afterwards? On the other hand, there are some other competitions that have free tasks, so the teams can freely choose what they want to present. And then, well, the risk is that comparability among the teams is really hard. So let me give you some examples of these types of competitions. Here, those involving grasping or picking actions mainly. So the most famous one is the Amazon Picking Challenge, which afterwards was turned into the Amazon Robotics Challenge. And there was these tasks to pick items from a shelf and then place them to fulfill an order, and then afterwards also refilling the shelf after the order. So this brought a lot of advance in terms of design of grippers and integration of the full system for robotic planning. And actually we saw during the competition a lot of very novel designs. There was also the Real Robot Challenge that we just learned today about, and it will be also planned for this year. So these are actions that are really focused on the grasping ability. We can move to the next slide. Then some of the competitions require some manipulation. So it's not purely the grasping action or just pick and place tasks, but also some manipulation. So changing the object pose during the motion or placing it on a special configuration. And you see here two of them. One is the Open Cloud Robot Organization Challenge that we will have later today, the explanation. And it was focused on reorganization environments on a tabletop scenario. One other type of competition was the Cybathlon arm prosthesis race, which is not exactly robotics, but many of the methods in robot hands are shared actually with the design of prosthesis. There are some fixed tasks as well, and you see here some examples like picking the keys from one place and then putting them on this hook, or on the right side, a person hammering a nail. Of course, this is an amputee, so actually they come up with some creative ways to solve the tasks, as you can see on the picture. So this is not an error. Actually, this is exactly how the person was hammering the nail. Good, let's move to the next slide. Some other competitions involve assembly, which of course is one additional stage of complexity, because you not only have to detect the part and pick and place it in certain configuration, but also you have to consider the order to do those tasks. We saw on the World Robot Challenge, for instance, one assembly of this pulley mechanism, and in the Robotic Grasping and Manipulation Challenge, we have had this industrial track from the beginning on the editions that we've had, and NIST has supported the competition by providing for all the events one assembly board that is focused on a different set of tasks. In this case, you see on the bottom right, one board that has this assembly of a small pulley mechanism and some cable routing and connectors on the board. Good. Finally, in the next slide, we see some competitions involving mobile manipulation, which is, of course, very related to our problems. The most visible one is the ERL, the European Robot League. They have a subset of competitions called the Smart City Robotic Challenge, where they have a mobile platform doing some shelving tasks, in this case at the Iago platform. And actually the same robot was used in the IROS mobile manipulation hackathon, which took place in 2018 and will take place again in 2021. And this competition is one of these events that has 3 tasks. So all the teams can decide what task they want to do using the same basic hardware platform. The advantage is that it simplifies a lot the competition, in the sense that there is a company that is supporting the hardware and providing on-site technical support. Teams can completely forget about transporting equipment with all the costs and logistics that this implies. However, the comparability of multiple solutions is really hard. It's more for displaying the state of the art in a particular field. So with this overview, we can move on, and Joe will introduce us to some additional examples on the assembly tasks on the task boards.
Sure. Hello, everyone. I'm Joe Falco from National Institute of Standards and Technology, also usually known as NIST. So we've developed a series of assembly task boards to support the manufacturing research community in robotics. We see that assembly is a critical operation for most manufacturers, yet it is underserved by automation such as robotics. In the research community, we see that there's been a lot of focus in the past years on service robots. And so we're trying to get people interested in the manufacturing problems, which still exist and are pretty complicated, especially with the onset of small and medium-sized manufacturing environments. Just to let you know, over 90% of the manufacturers in the US are small and medium-sized manufacturers. They have their own issues when trying to implement robotics, but there's the opportunity for lots of solutions in those environments. So we currently have 3 task board designs that focus on small parts assembly. These include a common connectors fasteners board, which is our first one. I think you saw it earlier in Adam Norton's presentation. We also have a pulleys and gears task board, a cable routing task board with deformable objects on both of those. And currently we're introducing a wire harnessing task board. More information on these task boards can be found in the link at the bottom of this slide. The next slide, please. So the competition design, what we did was we introduced these task boards to this robotic grasping and manipulation competition that you started, and evolved into a manufacturing track along with the service track. These competition task boards draw from the primary NIST task boards I talked about on the first slide. So we pull in objects from each of those competition boards to construct a single competition board. What we do is we award partial points for per operation based on how well each task is completed. Sometimes someone might not thread a bolt fully, things of that sort. We limit competition time and we apply a bonus to any remaining time. And this is used to encourage autonomous operation. We don't want to see a lot of teach programming, which we do sometimes, but as this competition has evolved, and I'll talk about this soon, we see that solutions are evolving and they're paying more attention to what we say is more important to small and medium-sized manufacturers. So it's a learning curve. We're teaching the robotics research community what the problems are for small and medium-sized manufacturers. We also encourage the use of perception, both machine vision and force sensing, and we encourage the use of CAD data, which is something that's not typically available in the service robotics community, but is usually always available in a manufacturing environment. We also let teams use multiple robots, multiple hands or robotic grippers or hands supporting tools. They can carry tools, electric screwdrivers and the such. And we also allow for automatic end effector and tool changes. They have to be automatic. Everything has to be autonomous once the operation begins. We also use limited use of perception markers also for locating the task board itself, as well as the layout of parts presented for assembly on a kit. Next slide, please. So this just gives you an idea of where we are with the task boards. We started in 2016 when we met up with you, and we helped them introduce a couple of manufacturing type tasks into the service robotics track. The following year, we introduced our primary NIST task board 1 into the challenge, along with the World Robot Summit folks who were preparing for the 2018 challenge, came in with a subassembly for gears. So there were 2 tasks within the manufacturing track of the competition. The following year in 2018, WRS held their competition. We did not hold the IRAS competition. They would have been around the same time. And then following in 2019, we introduced another task board to the competition, which was a conglomeration of all the different tasks that were on the NIST primary task boards. We used pretty much the same task board in 2020, which was remote. And the remote challenge had some good aspects to it, and that the competitors got to work in their own environments with the same lighting. Some of the systems are quite complex, so it made it a bit easier. And in 2021, we plan to hold another competition at IROS. The venue will also be remote. Additionally, some other competitions being held are Robothon and World Robot Summit 2020 in 2021 because of COVID. I think it's being held, I'm not sure yet. I should also mention that WRS World Robot Summit also used the same task board concept. So they have a main assembly, but they also break it into a task board, similar to the way NIST does its task boards. Next slide, please. So what solution outcomes to date? So teams vary from year to year, which is unfortunate because there's a lot of lessons to be learned, but some teams do come back and compete in consecutive years. The venue-based competition in the past has presented some performance issues. So you're plugging your system into venue power and you're dealing with venue lighting, and that has been an issue in the past. So teams competing in consecutive years, so I see no indication of better performance. This is probably due to the fact that tasks change from year to year. Teams typically try to upgrade their systems. What I really have liked seeing over the past years is that teams are starting to implement CAD models into their solutions. And those sometimes present problems too. It's a new environment to them. And a one-shot test may not be the best performance indicator. Ideally, these task boards would be brought back to your laboratory to do benchmarking with multiple runs. And that's our intention. We use the competition to essentially promote the use of these task boards for benchmarking back at your home space. And then to the right, you'll see a couple of images from some of the better performing teams. SDU got a first place. They were the only team to ever complete the task boards in its entirety and gain bonus points. And I think they did this because of their solution was multifaceted: tool changing, multiple vision, force sensing. They used some AR tag technology. They had a lot of tool changing operations, holding tools, multiple robot systems. So I think that one of the indicators for solutions and how to scope out what the benchmark is and how well the solution did would be to also measure the cost of the system, which is not so easy to do. But I think it in comparison to other systems, it's important to be able to at least document that into the benchmark. In any case, you can take a look at the results of the 2020 competition. There's videos there for both the service and manufacturing track. Okay, I think there's one more slide and I'm done. So so this just kind of describes what this year's competition is. It consists of a wire harness as we're designing into our number 4 NIST task board. So on this task board for the competition, you'll build a small wiring harness. As well, you'll build a small mechanical assembly, which is a drive mechanism. And when you remove your wire harness from the construction area and plug it into the mechanism connections, you should be able to move your mechanism back and forth as an ultimate goal for success. More details can be found. They're developing details as we're designing the solution now on the website here. I think that's it. There's one final slide that points to, I'd like to recognize Kenny Kimball. He does all our task board design and works closely with me on this. We have a publication on assembly task board, and there's also a link to our benchmarks for characterizing robotic end effectors, which is kind of geared towards robotic hands too. So encourage you to look at that too. Thank you very much.
All right, thank you, Joe. So next, I'm going to introduce the service track in the recent robotics grasping and the manipulation challenges. So the challenges has been run for 4 years, 4 times in the last 5 years. And as Joe mentioned, we skipped 2018. And among the years, we had combined about 20 unique tasks. And so over the years, we see a lot of improvement in the performance in the service track, but at the same time, we gradually increase the difficulties of the tasks. And from the very beginning, we had a hand-in-hand, which has absolutely no perception, using human perception. And even for the automation side, it was a limited perception. To the current years, we actually have everything randomly placed and even ask people to move them around to make sure they are random. And at the very beginning, we basically allowed the teams to basically try and multiple times. And if it works one time, we recorded the best score of that try. And now we basically say, okay, you have to do this 5 times. We can do the average. Next, thanks. So among the tasks, we basically design those according to research challenges we kind of pre-identified. So this is a competition, mainly try to connect the research community with real applications, but at the same time, we try to really draw out of those challenges and relate to research. So for the perception challenges, we usually have difficulties with shiny objects and translucent objects. And a lot of times the sensors are kind of not very good in terms of precision and accuracy, and things are getting better. And we can see along the way the performance are getting better. And to reflect to those challenges, we design a task for those. For example, we ask teams to pick up silverwares, and a lot of those are polished, and like spoons, forks, and knives. And we also ask them to pick out metal objects like tongs and etc. And one extreme case, we ask them to pick up ice cubes. So many of those tasks have a lot to do with perceptions. I'm not going to read through them one by one. Next. Right, so because this is a grasping and the manipulation challenge, we also look into the challenges by just looking at the grasping itself. And a lot of times, the objects may not have a very good shape for simple grasping, and they may not have a very good surfaces. And for example, we ask teams to transfer cup on saucer, which has a very narrow edge. It's difficult to grasp. And we also ask people to grasp objects in clusters. And I think many of the competitions has that part. And the regrasping is also a very difficult direction. And we featured picking up spoons. And a lot of times we observe the people who pick up the spoon from a drawer and that is not the best to do picking, so they have to not the best to use the spoon. They have to place the spoon at a certain position and then regrasp it. So that takes a lot of time, and we clearly see regrasping is a big challenge. And the grasp for manipulation, how we grasp a hammer to hammer nail, for example, and inserting pegs also has a lot to do with how we grasp for that particular manipulation. And grasp for in-hand manipulation is another quite important and challenging problem. At the beginning, we asked people to do extend and press syringe. And for us, we can do that with one hand, and none of the teams was able to do it. And another thing will be using scissors, and also it's very challenging. Nobody was able to do that. Next. Among them, we also designed a few tasks that's reflecting the challenges in manipulations. For example, because of imperfect perception, and a lot of manipulations may fail. And quite popular examples are inserting things like play with board and putting objects on a board, inserting pegs, and so on. And manipulation also, a lot of times need accurate prediction because you want to know what actually will happen, like pouring. And sometimes we're using deformable object like hanging tiles to basically you need to know how the tiles are going to move so you can perform that. Next. So we had a brief summary on the progresses we observed in the latest competitions. And for different kind of challenges, we basically summarized what actually worked and what has been solved. And we basically put this into our letter special issue submission. So I'm not going to go through this one by one, but just let you know, we found a lot of them has been, over the years, has been solved or closely being solved. And there are still some open challenges. For the next page, you're probably going to see. Next. Oh, not this one, next then. So this page, we basically just tell you what we have done in the last two challenges. And one is we basically asked the team to make 5 cups of iced matcha green tea. On the right side, you see all the objects the teams has to manipulate and pick up and manipulate. And one very challenging, if you look, is the ice cubes. It's difficult for the teams to pick up ice cubes with tongues, and among many other things. Next. So this will give you a breakdown of those of the making tea project the task. The task has 8 tasks, 8 steps, and we provide different scores for different steps, and basically based on how difficult they are. And I'm happy to report the teams were able to do 6 after the 8. Not one team can do that, but combined, all teams, you know, this task can be done by this team, this step can be done by that team, but combined 6 of the tasks can be done by the teams. And 2 of the tasks are very challenging. None of the teams could do it perfectly. One is add 2 ice cubes into the to-go cup. Another one is put a lid on the to-go cup. The second one is a little bit easier, I guess, you know, 87% of the time for the best team. Next. And look back to the first 2 years, and there are also 3 tasks nobody was able to do. One is hammer nails. Another one is fully extend the syringe, as I mentioned before, and also using scissors. Those are quite challenging for in-hand manipulation. and hammer nails require you have quite a strong hand and arm. Next. So we are currently working on a design of next competition, which is going to happen this year. And for the service track, and we thinking about set up a dining table, for example, and we're going to have people to pick up spoons and knives from our organizer, and we will have people to pour waters and into cups from a pitcher. And you can also see I have wine bottles, beer bottles, and the beer cans. But those are just ideas we currently have. We're probably going to maybe able to discuss this a bit more in the panel discussion. And also you see the ice cubes. We're also probably going to continue with the ice cubes. So setting up tables and essentially prepare for dinner could be the tasks we're going to have this year. All right, next. Thank you. And I look forward to the discussion.